Hello friends, this video Conic Section Part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Conic Section Part 1 to Part 6. Let me introduce to you a new term called ellipse. Ellipse is the set of all points in a plane, some of whose distance from two fixed points in the plane is constant. Please let me repeat again. Ellipse is a set of all points in the plane. The sum of distance from two fixed points in the plane is constant. For example, we have two fixed points f1 f2. This distance, this is let's suppose p1. So p1 f1 plus p1 f2. This will be equal to, let's suppose we take one more point p2 f1 plus p2 f2. Or we take again one more point, this is P2 actually. Let's take one more point P3. This will also be equal to P3 F1 plus P3 F2. What I'm trying to say is that sum of distance between any point, example this, sum of distance of this point from F1 and F2, this sum will be equal to P1 F1, P1 F2. To draw this, you can just take two nails here, put a thread and take this pencil. You revolve this pencil, move this pencil in this direction, you will get an ellipse. Why? This distance is always constant. So that means this plus this distance is constant because we have taken one thread. This is tied actually, this thread is tied. We have taken one thread of this length, that is L1 plus L2 plus L3. Total length of thread is L1 plus L2 plus L3. And now if you move this thread like this, since this length is constant, so whatever point you reach in that thread, these two distances will be, sum of the two distances will be L1 plus L2. Correct? So what we get is a ellipse. So in case of ellipse, set of all points in a plane, sum of whose distance from two fixed points, we have two focus here, is constant. Let me repeat. In case of ellipse, you take any two points, sum of distance from two fixed points is constant. I'll draw here. Let's suppose this is f1, this is f2. Let's suppose. Now you take a point p1. Sum of distance between P1 and this plus this, let's suppose equal to this plus this. This is L1 and this is L2. So this is L1 plus L2. You take any other point here P2 such that this distance and this distance is also L1 plus L2. Similarly, you keep taking this a point like this, you will get so many points. And if you draw more points, like this, you will get ellipse. In case of ellipse, any point in the ellipse, and we have two fixed points, sum of the distance is constant. In case of ellipse, the longer axis is called major axis and the smaller axis is called minor axis. For example, if you draw an ellipse like this, so this, the longer one, this one will be major axis, and this one will be minor axis. The longer one is major axis and the minor one is minor axis. Focus is always on the major axis. Focus will always be on the major axis. Correct? Half of major axis is called semi-major axis and half of minor axis is called semi-minor axis. Semi-major, this is also called semi-major radius and this is also called semi-major radius. So semi-major axis is also called semi-major radius because this length is called semi-major radius from here to here, and this length is called semi-major radius, This is called semi-minor radius because this is minor axis. This is R minor and this is R major. Got it? Major axis is the longer axis and the focus always lies on the major axis. Half of major axis is called semi-major axis and the length is called semi-major radius. Half of this minor axis is called semi-minor axis and the length is called semi-minor radius. Let's see some terms in ellipse. The two fixed points are called foci because they are two. Focus is singular, foci is plural. Repeating once again, the two fixed points are called foci or foci. These two fixed points are called foci or foci. The midpoint of the line segment joining two foci are called centers. This is the center. The line segment joining the foci of the ellipse is called major axis. This is the major axis and this is always the longer one. The line segment perpendicular to major axis and passing through center is called minor axis. This is the minor axis. And the end points of major axis are called vertices. Please note, these are the end points of major axis, not the minor axis. We don't have any name for this C and D, but for A and B we have the name called vertices. So we have major axis, minor axis, foci and center and also vertices. And we have two foci. This is the naming convention in ellipse. Also, half of semi-major axis is called semi-major axis. This is semi-major and semi-major is also called major radius. Similarly, half of minor axis is called this length from here to here, this length is called semi-minor and it is also called minor radius. Now let's talk about length in ellipse. Distance between center, that is 0, 0 and foci is C. Also, both are C because this is symmetric. Also, the distance of major axis is 2a. This is major axis. This is 2a. Similarly, for minor axis, this is 2b. So vertices are at a distance. This will be a comma 0. This will be minus a comma 0. So vertices are a comma 0 and minus a comma 0 distance. These are vertices. So what we have seen, the distance between two foci is 2c. The length of major axis is, I'll see, 2 foci distance, d of 2 foci is equal to 2c. Correct? Major axis distance is 2a, minor axis this is nothing but 2b. So we have 2a, 2b, 2c. Please note, these are the naming conventions 2a, 2b, 2bc, and we'll now find a relation between a, b and c. So the relation between a, b and c is a square is equal to b square plus c square. So we prove this. Let's take this point P here. P is this ellipse. We have to find this, prove this. This is B, this is C, the root square, B square plus C square. Now to prove, what we have to do is, we'll take this point P. Since P is in the ellipse, is part of this ellipse, we can say that F1P plus F2P, you can say that F1P plus F2P, this is the common length. They should be equal to, if you say this Q point, that is F1Q plus F2Q. This will also be equal to f1r plus f2r, correct? Because you take any point in the ellipse, the distance sum from two foci is constant. So now let's try to find a constant distance. So let's find f1p plus f2p, this distance. So f1p is nothing but, if you see, f1p is nothing but f1o, this distance, plus OF2, this distance, plus, or we can say OP. F1P plus F2P is nothing but F1O, because we know this, or let's, okay, F1PO plus OP, because we know F1O, that is C, and we know OP, that is A, plus F2P. F2P is nothing but A minus C, because this whole thing is A, this is C, this is A minus C, because this OP, or we can say this is nothing but OP minus OF2, correct? What we get is C plus A minus C. This is equal to 2A. So the common distance is 2A, correct? Now we see that since this B is F1O is B, this is B, this is C, this is a right triangle, this is root B square plus C square. Similarly, this is B, this is C, this is root B square plus C square. Now we know that F1Q plus F2Q is also equal to this value, F1P plus F2P, and this is nothing but, we have found this is equal to 2A. So we can say that F1Q plus F2Q is equal to 2A, correct? F1Q is root B square plus C square, root B square plus C square. F2Q is also root B square plus C square plus root B square plus C square. This is equal to 2A, or 2 of root B square plus C square is equal to 2A. 2 cancel, or we can square this also. So we get B square plus C square is equal to A square, and that is what we are supposed to do. Please note, in case of ellipse, distance between two foci is C, that is 2C. Distance of major axis is 2A, distance of minor axis is 2B. So we have A, B and C. The relationship between A, B and C is A square is equal to B square plus C square. Now let's discuss special cases of ellipse. Case 1, C is equal to 0. When C is equal to 0, A is equal to B. We'll prove that. We know that C square is equal to A square minus B square. We have just proved. Now you put C is equal to 0. So this you get A is equal to B. A is equal to plus minus B. But since we are talking only about the length, so we'll take positive one. A is equal to B. So when A is equal to B or C is equal to 0, either of this case, both the foci meet. So this is a circle. So when C is equal to 0, this becomes circle. Similarly, when C is equal to A, we have this formula C square is equal to A square minus B square. When C is equal to A, C square is equal to A square minus B square. So this becomes A square and C square cancel because A is equal to C. So we get B is equal to 0. So there is no minor axis. In case we get straight line. You see, this is a straight line. So we have two special cases of ellipse. First case, C is equal to 0, we get circle. Second case, C is equal to A, we get straight line. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.